Hey there, AI enthusiasts. Welcome back to Learn AI with me. I'm your host, Manoj, and today we're diving into one of the most exciting and transformative technologies in artificial intelligence, deep learning. You've probably experienced deep learning in action without even realizing it. Think about how your phone unlocks just by recognizing your face, or how Netflix seems to know exactly what you want to watch next. That's deep learning working behind the scenes, making our lives easier and more connected. I remember the first time I saw deep learning in action. I was experimenting with an AI art generator, and I typed in something wild like a futuristic city with flying cars at sunset. Within seconds, the AI created this stunning image that looked like it belonged in a sci-fi movie. I was blown away. It felt like the machine had read my mind and turned my imagination into reality. But how did we get here? How did deep learning evolve into the powerhouse it is today? That's what we're going to explore in this episode. We'll start with the basics of what deep learning is, then take a journey through its fascinating history, the breakthroughs that made it possible, and the different types of deep learning models that power today's AI. So, grab a cup of coffee, get comfortable, and let's dive in. What is deep learning? Let's start with the basics. What exactly is deep learning? Imagine you're teaching a child to recognize a dog. You wouldn't give them a checklist like forelegs, fur, tail, barks. Instead, you'd show them lots of pictures of dogs, and eventually, they'd figure it out on their own. That's how deep learning works. Deep learning is a type of artificial intelligence that mimics the way our brains learn. It's part of the broader field of machine learning, but with a special superpower, it can automatically discover patterns in data without being explicitly programmed. Here's a simple analogy. While traditional machine learning is like following a recipe with specific instructions, deep learning is like a chef who experiments with ingredients and learns to cook by trial and error. It's more flexible, more powerful, and often more creative. History and evolution of deep learning. Now, let's take a trip back in time to see how deep learning evolved. 1943, the birth of neural networks. It all started with Warren McCulloch and Walter Pitts, who created the first mathematical model of a neuron. They showed that neurons could compute binary outputs based on inputs, laying the foundation for artificial neural networks. 1958, the perceptron. Frank Rosenblatt developed the perceptron, the first algorithm for supervised learning. It was a single-layer neural network that could classify data into two categories. But it had limitations. It couldn't solve problems that weren't linearly separable, like the XOR problem. 1986, backpropagation. Fast forward to the 1980s, when Geoffrey Hinton and his team introduced backpropagation. This algorithm allowed multi-layer neural networks to learn from their mistakes, making it possible to train deeper networks. 2012, the ImageNet breakthrough. One of the biggest milestones came in 2012, when AlexNet, a deep convolutional neural network, won the ImageNet competition. It reduced error rates by over 10% and showed the world what deep learning could do. 2014, generative adversarial networks, GANs. Ian Goodfellow introduced GANs, which allowed AI to create realistic images, videos, and even music. This was a game changer for creativity and generative AI. 2017, Transformers and NLP. The introduction of the transformer architecture revolutionized natural language processing. Models like GPT-3 and BERT, which are based on transformers, can now write essays, answer questions, and even hold conversations. 2020, AlphaFold DeepMind's AlphaFold solved the decades-old problem of protein folding, a breakthrough with huge implications for medicine and biology. Types of deep learning models. Now that we've explored the history of deep learning, let's talk about the different types of deep learning models. These models are like tools in a toolbox. Each one is designed for a specific type of task. Here are some of the most important ones. Feed-forward neural networks, FNNs. These are the simplest type of neural networks, where information flows in one direction, from input to output. They're great for basic tasks like image classification or regression. Think of them as the foundation of deep learning. Convolutional neural networks, CNNs. CNNs are designed for image-related tasks. They're like pattern detectors, identifying edges, shapes, and textures in images. For example, CNNs power facial recognition systems and even medical imaging tools that detect tumors. Recurrent neural networks, RNNs. RNNs are perfect for sequential data, like text or time series data. They have a memory that helps them process information over time. For instance, RNNs are used in speech recognition and language translation. Long short-term memory networks, LSTMs. These are a special type of RNN that can handle long-term dependencies. They're used in tasks like text generation and machine translation. For example, Google Translate uses LSTMs to understand and translate languages. Generative adversarial networks, GANs. GANs are like creative artists. They have two parts: a generator that creates data, like images, and a discriminator that evaluates it. GANs are behind deepfake technology and AI-generated art, autoencoders. These are used for compressing data and then reconstructing it. They're great for tasks like anomaly detection or removing noise from images. Transformer networks. Transformers are the backbone of modern natural language processing. They use self-attention mechanisms to process text efficiently. Models like GPT-3 and BERT are based on transformers and can write essays, summarize text, and even hold conversations. Graph neural networks, GNNs. GNNs work with graph-structured data, like social networks or molecular structures. They're used in drug discovery and recommendation systems. Capsule networks, CapsNets. These are designed to preserve spatial relationships in data, making them useful for tasks like 3D object recognition. Reinforcement learning with deep neural networks, DeepRL. This combines reinforcement learning with deep learning to train AI agents for decision-making tasks, like playing games or controlling robots. Think of AlphaGo, the AI that beat a world champion in the game of Go. Each of these models has its own strengths and is tailored for specific tasks. Together, they form the backbone of modern AI. Deep learning has come a long way, from its early beginnings to the diverse range of models we use today. Each type of model plays a unique role in solving real-world problems, from recognizing faces to generating art, and even discovering new medicines. In the next episode, we'll explore how these models are transforming industries, the challenges they face, and the exciting innovations shaping the future of deep learning. You won't want to miss it. Until then, keep dreaming, keep learning, and stay curious. This is Manoj, signing off.